Alright guys, so I figured that I was going to screencast a video showing the example problems on the review sheet. So first off, I wanted to show you guys your reference sheet that you'll be able to use for the upcoming exam on Thursday, okay? So here you see that we have our periodic table right around here. And we also have our activity series, polyatomic ions, the most common ones that you may see on the exam, and a mole map showing you, again, going from moles to particles, particles to moles, moles to volume, and so on and so forth, okay? So this is going to be 30 question exam, okay? And don't fret, it'll be okay. Just study as much as you can. Just come after school for some help, and we should be good from there, all right? So let's go on to the practice problems. Excuse me. Sorry. My dinner's making a comeback, so just kidding. Let's get started. So for the beginning of this, let's talk about a chemical reaction and the conservation of matter, okay? Where are we at? So there we are. Okay, so in a chemical reaction, matter is always conserved, okay? So no matter what, the left side is always going to be equal to the right side. So that means that atoms are neither created, okay, so created nor destroyed, all right? So that means the left side is always going to have to be equal to the right side, okay? So let's keep going. So in the following equation, we're going to label the products and the reactants, subscripts, and the coefficients. So for this guy right here, this 5, it's in front of the molecule. So if it's always in front of the molecule, that means those are our coefficients, okay? All right, so if those are our coefficients, that means these guys right here, the small numbers on the bottom of the atoms, those are our subscripts, all right? Subscripts. Sorry, my spelling really bad today. So we see our arrows right here, right? So that means that our arrow on the left side of our arrow, those will always be our reactants, okay? Always, 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 always. That means if these are our reactants, that means these are our products. Whoopsie. Okay. Easy peasy, right? So let's keep on going. So right here, in a chemical equation, the subscript is the larger or smaller? Well, let's take a look. This number is a lot smaller than that, which in this case we are correct. It is the subscript. So that means that the subscript is the smaller number. Okay, so let's write in subscript right here. Subscript. All right. Oh, nope. Sorry. Mr. Delgado doesn't know how to answer questions here, right? Okay, so let's go back to our pen. Is the smaller number, all right? Oh, way too fast. Okay. And this number always represents the number of atoms, okay? So remember, atoms, those refer to each of those individual elements, okay? So the subscripts will always relate to the atoms, okay? So let's go ahead and change this guy right here. Should be coefficients, right? The coefficients is the larger number, right? Because if we look at back of our coefficient here, we notice that it is the larger number that goes in front of the molecule. So it is our larger number, okay? So let's go ahead and put larger right here. All right. And this number typically represents the number of molecules, okay? So these molecules are always the ones that are in unison, all right? So let's take a look at here. So C3, if we were to look at C3 by itself, that'd be an atom. we'd be saying that there are 3 atoms of carbon, C. But if we're going to look at all of this together, okay, if we take a look at all of this big number right here, this entire compound, we could say that that is our molecule, all right? This is our molecule. And our atom, might as well, this is pretty cool. I'm having fun with this, guys, if you haven't noticed. So we'll take a look at this oxygen right here. Try not to get that. Uh-oh, got a little bit of it, but it's okay. Let's see if I could see. Where's my cursor? There it is. Let's get that highlighter. Try to get that oxygen. Boom, right there. Okay, so that oxygen right here. You get the picture, right, guys? I hope you do. That oxygen right here. Oh no, I'm sorry, guys. I don't know what I'm doing here. Okay, anyways, I'm just going to go ahead and just do a little highlight real quick, or underline for what I'm talking about. So this oxygen right here, we could look at that and we could consider that oxygen by itself as a atom. Okay, just because the oxygen by itself right here, it's just oxygen. It's one oxygen. There's no subscript right here, right? So if we were to look at that oxygen by itself, it would just be an atom, okay? Hopefully you have no more questions. So let's keep going. It represents the number of molecules. So let's get this written in here real quick. Molecules, all right? Let's keep it going. Okay, so in this problem right here, you'll notice that we have one element A. You have an element B. And you have an element here. What happens to A and B? They come together. And they make a brand new new compound, okay? So you notice that A and B combine after the reaction, and we get a brand new compound, okay? So this is the type of reaction such as the synthesis reaction, okay? Synthesis reaction, all right? So let's go ahead and balance this equation out. So here I have 1P. Here I have how many O's? I have 2 O's. All right, let's look at this side. So P right here, whoops, I have 2 P's. Oxygen here, I have 5 oxygens. All right. So there's a couple ways that we could do this, okay? There's one way where you could think of how can I get 5 oxygens total on this side, all right? Or we could think about just making this odd number of oxygens into a positive. Okay, that might help us even better. So let's look at the putting a 2 in front of here. What if we put a 2 in front of there? What happens here? We changes this to a 4, changes this to a 10. Oh, that's a lot more doable, right? We could make 10 here on this side because I could just put a 5. Because 5 times 2 gives me 10. And then all we have to put right here in front of the P is what? Oh, let's just put a 4. Then we get a 4 on this side. P's check out and the oxygens check out. So that's a little shortcut method. You got to think of intuitively right there for a little bit. So you got to think about it. How can I turn this 5 oxygens into 10 oxygens? How can we do that? Okay, that's what we're thinking about. 5 oxygens into 10 oxygens. How can we do that? Oh, well, just multiply by 2. Okay. Simple problem solving process. Okay. I hope that made sense. Let's keep going. I like using different colors. This is a nice feature of this writing tablet. Okay. It's pretty sweet. So this type of reaction, you want to look at this reactant, this product, and this product. Okay. If it has these 3 consistent elements and compounds, molecules, carbon dioxide, and water as products and a reactant of oxygen, it'll always be a combustion reaction, okay? So this is just where it comes down to you guys studying the types of reactions and just understanding and being able identifying these patterns. If there's a product of a carbon dioxide and a product of a water molecule, boom, there is your reaction, okay? Combustion reaction. All right. So now's the fun part. Let's balance. So we have carbon. Carbon, there's two elements. Hydrogen, how many hydrogens are there? Oh, there's 6. How many oxygens? Oh, there's 2. To the left, right side. How many carbons? Uno. Oxygens? Dos. Wrong, Mr. Delgado. Can't do math. There's not 2 oxygens. There are 3. Can't forget that guy over there. And then hydrogens. How many hydrogens do we have? We have dos. Okay. So let's first balance the carbons. So if I put a 2 right here, what happens? This guy goes to 2. And what does it change for the oxygens? It changes from 4 to 5. All right. Let's change the oxygens now. How many hydrogens? If I change my hydrogens, I need a 3 on this side to make 6 because that's what I need on this side. I need 6. So if I change this guy to 6, now I have how many oxygens? I have 7. Oh, it's beginning coming kind of nice. So what can we do here, fellas? Well, there's 2 things. Let's first figure out how can we get 7 oxygens right here. Oh, well, that'll be easy. What's 7 divided by 2? Because we have 2 oxygens already here. So we need a coefficient that we're going to put in here that multiplies with oxygens 2 already, subscript, to make 7. So you can think of it as a math equation too. You can think of it as 2 times x equals 7. Solve for x. Divide by 2. Divide by 2. X equals 3.5. So that's what we need. We need 3.5 right here. Are we done? Nope. No bueno. We're not done yet. Why? Because we cannot have a 3.5 coefficient. That is a big no-no. Okay, we can't do this. So that means the only way that we could fix this problem is by going back into each of these coefficients and multiplying by 2. If we multiply by a common factor or multiply by a common term, we are able to manipulate our reactions coefficients. Okay, so we could change this 3.5 into a brand new number. Okay, so here, if I do 2 times 1, I get 2. If I do 2 times 3.5, I get 7. If I do 2 times 2, I get 4. If I do 2 times 3, I get 6. So these are my coefficients, okay? 2, 7, 4, 6. Okay, so make sure you review this if you need a little bit more help, and make sure that you understand that this is a common process to get rid of this decimal right here. Okay, so now let's go back and count how many each of these have. So we have 4 carbons, we have 12 hydrogens, and we have 14. Sorry, I can't do math, guys. Sorry, can't do math. Oxygen. So over here, same thing. We have 4 carbons, 14 oxygens, and we have 12 hydrogens. So each of these do indeed check out. All right. Hopefully this makes sense. Like I said, take it step by step. That's why I'm doing the screencast, just because it's going to be tough. It's tough to do this in front of you guys and making sure that you guys understand. This is just the easier process. All right. So last one. Look at these. See out here we have A, B. So NO3 all together is B. Okay, guys. Any anion, even though it's a polyatomic ion, it's okay. We can still consider it as one entire term as B. So here we have C and D, and look what happens. C now is bonding with B, and now A is bonding with D. So look what's happening. We have 1, 2, 3, 4 different elements, and what happened to them? They swapped partners. So since we have two compounds and they swap their partners, we have a double replacement reaction, okay? So make sure you understand that ABCD turns into CBAD. So you notice how C is now bonding with D here, right? D is right here, but D's over here now. And what happened to purple? So we have B right here. We have B right here. And then we got A right here and right here. Okay, so just trying to show you guys the difference in between the two different compounds and how they swap their partners, all right? Hopefully this makes a lot of sense, all right? So let's go ahead and get rid of... Oh, I can't get rid of that? That stinks. So I have to undo. There we go. It'd be easier without that highlighted gunk on my computer. Okay, so let's go ahead and figure out what's happening here, right? So let's go ahead and balance the equation. So we got an Na, we got an N, we got an O, we got a P, B, and I think that's it. So how many NAs do we have? We have 1. How many N's? We have 1. How many O's? We have 4. And how many PBs? We got 1. So let's check out this side. How many NAs? We got 2. How many N's? We have 2, because remember this 2 goes to the N and it goes to the 3, okay? So we have 2 N's. How many O's? We have 7. And how many PBs? We have 1, all right? So let's go step by step. Let's look at balancing Na, okay? The first term, let's just go ahead and go do that. So how many NAs do I need on this side? I need 2. So let's put a big O2. Oh, huge stinker. Sorry. Put a whole big O2 right here in front of Na. So now we change the Na to 2. Now we change the N to 2. And now the oxygens, we have 2 times 3, which is 6, plus 1 is 7. And then let's balance something else now. Oh, look at that. Just one coefficient and everything is balanced. Okay, so sometimes you're going to run into some of these problems. It looks daunting at first. It looks, oh my gosh, how am I going to do this, Mr. Delgado? But you know what? Just start it. Go with the process. And you'll see sometimes it's just an intimidation factor. It's real easy to do sometimes, all right? So let's go ahead and start with number 5. So number 5, we're going to identify these types of reactions, okay? So let's go ahead and read these aloud and start thinking about it, all right? So a hydrocarbon. So a hydrocarbon, what this means is a CH molecule, okay? This is a hydrocarbon, CH. So it could be CH4, it could be C2H6, it could be any of these, okay? So this is a hydrocarbon. So it says a hydrocarbon reacts with oxygen to make carbon dioxide and water. Uh-oh, aren't these 2 signal keywords right here? They make, or in other words, those are our products, carbon dioxide and water. So if those are our products, that means that this has to be a what type of reaction? You're right, a combustion reaction. Okay, good. So here it says one element. So an element means something by itself, like chlorine or oh, pardon me, guys. Woo. Like chlorine or something like carbon. Carbon won't be by itself. I lied. Something like lead or calcium. Okay, all of these are elements. Reacts with a compound to form a new compound and a different element. Okay, so this sounds like element, one single element. So it sounds like something. This is what goes through my head. So one element, A, it reacts with a compound, say BC, and it forms a brand new element. So I'm thinking AC plus B. So what does this look like, guys? This looks like a, yes, you're right. You guessed it, single replacement reaction. Okay, so that means one element comes in, interacts with another compound, which is two elements combined together, bonded together. Okay, and it comes and breaks up that bond, and it forms a brand new compound. Okay, so remember, in order for us to determine if that reaction can occur, we have to look at the activity series. Okay, so that is very important. We have to look at that activity series. Okay, guys. All right. So let's look at number 3. Okay, one compound. Okay, so that's something like CaCl. Okay, something like this. One compound is broken down into two or more substances. Okay, so that sounds like something like this. A, B breaks down into two substances. What type of reaction is this, guys? This is a decomposition reaction. All right. Decomposition reaction. Okay. And that means the last one, two compounds combine and produce two different compounds by trading metals. Let's see, there we go. So that sounds a lot like something like this. AB plus CD gives us AD plus CB. This is what this sounds like. Okay, so we have 1, 2, 3, 4 different elements. So two compounds combine and produce two different compounds. That sounds a lot like a double replacement reaction. All right. So hopefully this review is going well for you. So at any time, take a moment, pause, go back, rewind, contemplate on a few questions just in case you need to hear it once again, or it takes a little bit longer to, process it, take some time with it. Don't rush through this, okay? This is a very valuable resource that will help you prepare for the upcoming exam, okay? So let's go on to problem 6. We're going to complete and balance the following equations. So we're going to have to take our previous knowledge on different types of reactions, and we have to predict what's going to happen. So we have to think about what happens when I have one element by itself here, Li, and another element by itself. In this case, it's a diatomic molecule, so it occurs naturally in two. We have two single substances. They're going to react together. What's going to happen? We have to think about it. Okay, so one combines with another to make a brand new substance. So we know that Li is Li a metal or non-metal? So that's the first thing that we have to take a look at. So where's Li? Oh, Li is a metal. As you can see here. Let's see, can I write on here? Oh, I can. So we notice that Li is indeed a metal. Li has a charge of +1. Okay, So we need to know this whenever we're making brand new compounds, okay? That's very important for us to have, okay? So we know that Li, I'm going to do over here because we need the space to do the balancing equations and all that good stuff over here. Li has a positive 1 charge. Is fluorine a negative ion? Is it a nonmetal? Why, yes it is. And if we look at our periodic table once again, we can see that fluorine is indeed, let's use a different color. Fluorine is right over here, hanging out, and is on the negative 1 column. So we have fluorine that has a negative 1 ionic charge, okay? So let's go back to our problem here. Oh, where are we at, buddy? There we are. Okay, so I have Li. Now I'm going to have fluorine with the negative 1 charge, okay? So what happens? We have to swap, drop, and then what happens? They're both the same charge. So what does that mean? They cancel out, okay? So the last thing that we got to do is we got to balance. So how many Li's do we have? And how many F's? I have 1 Li and I have 2 F's. I have 1 Li and I have 1 F. So that means we have to what? We have to change the amount of Li's and F's on this side. I need 2 F's over here. So I get 2. I get 2. So that means I have to change the 2 over here. And that looks balanced to me. Does that to you? Of course it does. All right. Man, this is only a long video. Sorry. Personal note. All right. Here's our next problem. What do we have here? Notice that we have a compound A, Ca, compound B, Cl. We have a compound C, Pb. Remember, lowercase, it go together, so Pb. And NO3. Remember I told you guys about polyatomic ions? They will show up as anions or cations, and they will be considered as a 1 unit. So this is D. Okay? So if they were to swap partners, it would become AD plus CB. Okay, so AD, we're going to have calcium with nitrate. But before we do that, because are both of these Ca and Pb, are they both nonmetals or metals? They are both metals. So we have to take a look at their ionic charges. So we go back to here. Let's just go ahead and give this a good old erase. All right. So let's take a look. Sorry, guys. I get way too distracted here. All right. So Ca, we took a look on our periodic table. I even forgot to do that. Look at that. And we look at it, and it's right here. Ca is right here. So Ca, that has a charge of, since it's a column 2, has a charge of positive dose. All right. So we look at Ca over here, and we write Ca has a 2 plus. All right. For sake of time, we're going to just save Cl. We know that Cl is located at group 7. So Cl always will have a charge of -1. So what happens? The 2 comes over here, and this 1 comes right down here. And that means A and D. Whoa. Sorry, guys. That's why I can't be a YouTuber. I always mess up. We did A, correct? This is A, but we need D. We did A and B, so I was showing you why it's CaCl2. I was doing that on purpose. Don't believe me. Ca2 plus. Now look at NO3. Okay, NO3 is a polyatomic ion. Do not be afraid, guys. Go back to your reference sheet, and you will see. Oh, what? That was so weird. I'm sorry, guys. I'm just learning things as we go. NO3 is right here. And its charge is a -1. All right. So let's go back to over here and let's write down our NO3 And then what is the charge? -1. So that 2 comes over here. Why does that happen? I do not know why that always happens. Gosh, this is really irritating. What? Oh, that's going to be fun doing all those. So here we go. 2 plus comes down over here. And this 1 drops down in front of or in the back of CA. All right. So what does that mean now? AD, the compound is CA, parenthesis, NO3, close parenthesis, 2. All right. And then we add that to our next atom. Okay. So PB is a transitional metal. So we have to look at what the charge was for NO3. So NO3, we knew that it was a -1 charge. So if NO3 was a -1 charge, what did PB have to be in order for it to be bonded with NO3 without any subscript? So see here, there's no subscript here, and there's no subscript here. What does the ionic charge of PB have to be if the charge is canceled? You're right. The charge does indeed have to be +1. Okay. And that's the only way that we could see that PB and NO3 were able to combine together without any subscripts. Okay. So let's take PB. So we know that PB, let's see, now we're on C and B. So we know that PB has a charge of +1. Now what does Cl have a charge of? It has a -1. So what happens? Swap, drop. And we get what? We get PbCl. All right. Last but not least, let's balance. We have Ca, we have Cl, we have Pb, we have N, and we have O. There's 3 O's, 1 N, 1 Pb, 2 Cl's, and 1 Ca. This side, we have Ca as 1, we have Cl as 1, we have let's see, Pb as 1, we have N as 2, and we have O as 3. Okay. Oh, incorrecto mundo. We have O as 6. Okay. So let's go ahead and get rolling. So let's do Cl first. So Cl, if we notice that we have to get 2 on this side, we're going to have to have a what right here in front? We're going to have to have a 2. So Pb now changes to 2, and Cl also changes to 2. Okay. How about here? Pb is going to have to change over here, so let's put a 2 right here in front of Pb. Okay. Pb changes to 2. Oh, we also changed nitrogen, changes to 2. How many oxygens now we have? 2 times 3, which gives us 6. Oh, looks like we are balanced. Do you see that? Right? 1, 2, 2, 2, 6. 1, 2, 2, 2, and 6. All right. And that is it from there. Let's keep going. Bear with me, guys. This is some rough stuff. I know. Oh, we have a hydrocarbon here, CH. Remember, CH molecule reacting with oxygen. It's going to give us what, guys? I know you can do it. It's going to give us carbon dioxide and agua, H2O. All right. Well, then all we got to do now is balance. Okay, C's, we have 6, H, we have 6, and oxygens, we have dose. Okay, still on the right side. How many carbons do we have on this side? We have 1. Hydrogens, we have 2, and oxygens, how many do we have? We have 3. Okay, so let's get going, let's get cracking. So how many carbons do I need on this side? I need 6. Let's change this to 6. Now how many oxygens do I have? 6 times 2 is 12, plus 1 is 13. Okay. Let's Let's change the oxygens. I mean the hydrogens. How many do I need here? I need how many on the right side? I need 6. So what times 2 gives me 6? 3. So what happens here? It changes this to 6. 12 plus 3 more gives me 15. So now I need to get 15 on this side. It's one of those cases again. So what are we going to have to do? 15 or 2 times x gives us 15. And the x that's going to go in here is this x right there. So we're solving for this x right here. Divided by 2. Divided by 2. We get x is equal to 7.5. Does that sound right, guys? 7.5. 7.5 sounds fantastic. All right. So now we get rid of this x right here because we already know what that x is going to be. And it's going to be 7.5. Okay. But everything we're going to multiply by 2 because we want everything to be a whole number. So this turns into a 2. This turns into 15. This turns into 12. And this turns into 6. Okay. So let me write it right here on the bottom so it makes it a little bit more easier to look at. 6 right here. Okay. That means we have 12 on this side. We have 12 on this side. We also have 12 carbons. 12 carbons. And on this side, we have 30 oxygens. On this side, we have 30 oxygens. Okay? So please follow along these videos very quiet, quickly. Actually, not very quickly. What am I saying, guys? It's late. I'm tired. Just make sure that you're following these along at your own pace. Okay? There's no hurry when you're going through these. Please do not just go to the very end of a section and just copy down exactly what I did. That's not how you learn, guys. You got to listen to my thinking process and how this will help you guys understand this material. All right. I think that's it for tonight. I'm going to go ahead and go over the next one in a bit, the next slide. But for right now, just want to do this into 2 parts. So one part for the one part for the front page, and then another part for the second page. Okay, so as you can see, we did a lot today, guys. We did a lot. This is a lot of stuff right here. So good information, good stuff for you guys for your review for your test. All right. So like I said, go through this step by step. Please listen to my annotations and my advice as I'm going through these problems. Okay, I'm helping you. I'm here to help you guys. All right. Yeah. Any questions? Please come see me after school, during lunch, before school. Just a reminder: Wednesday, periods 2 and 4, you guys have your exam, and periods 1, 3, 5. Well, don't have a period 5 for your chemistry. 1, 3, 5, and 1, 3, and 7. Jesus. Your guys' test will be on Thursday. All right. Well, it's Mr. Delgado, and glad that you took this initiative to study for your guys' exams. All right. Take care.